Welcome to this lesson on vector addition, 3 essential methods. In this video, we'll explore how to add vectors using the tip-to-tail method, the parallelogram method, and the component method, with a real-world example to tie it all together. In physics and engineering, vectors are everywhere, from forces to velocities to displacements. A vector is a quantity that has both magnitude and direction. To understand how objects move or interact, we often need to add vectors together. And there are 3 main ways to do it. First, let's look at the tip-to-tail method. Place the tail of the second vector at the tip of the first vector. Then, draw a new vector from the starting point of the first to the tip of the second. This new arrow represents the resultant, or the sum, of the 2 vectors. In the parallelogram method, both vectors start from the same point. Imagine completing a parallelogram using the 2 vectors as adjacent sides. The diagonal of the parallelogram represents the resultant vector. This method is especially useful when 2 forces or velocities are acting from a common origin. The component method is perfect when vectors are at angles. Break each vector into horizontal and vertical components. Then, add the x components together and the y components together. Draw the new vector from the origin to the point defined by the sum of the components. Use the Pythagorean theorem to find the magnitude, and trigonometry to find the angle. Here's a real-world example. An airplane is flying north at 300 km per hour. A crosswind blows in from the west at 100 km per hour. The wind pushes the airplane eastward, altering its actual path. By adding the velocity vectors using the component method, we find that the airplane's true ground speed is about 316 km per hour, at an angle of 18.4 degrees east of north. Let's summarize. Use the tip-to-tail method for a visual step-by-step approach. The parallelogram method is best when both vectors act from a single point. And the component method is ideal when you have angles and need precise calculations. All 3 methods give the same result. Choose the one that suits your problem. Great job! You've just learned how to add vectors in 3 different ways. Try practicing with different problems to build your confidence. If you found this helpful, subscribe or check out the next video on resolving vectors. See you there.